All right. You're sharing your screen, Eric?
Not yet, sorry. Yep. So today we are continuing the discussion started last week about some potential collective work for this year. Sorry, trying to find my screen. Here you go. Sorry, I'm not sure the screen is shared. Can you see my screen?
We see Venkatesh on your screen, and now we see a spreadsheet.
Ah, thank you. Yes. So last year we started to lay out, well, first to talk about different ideas, okay? Also to lay out a kind of maybe technology stack we could cover, we would need or we would be motivated to use. Okay? This week we need to talk more. Okay, we had last week was more brainstorming and not yet any form of convergence. Okay, we were starting to break down this document into different sheets, and toward the end we were talking about some maybe mission parameters. Okay, because we saw that some topics could help, to narrow down to narrow down decisions basically. Typically power, okay, power energy requirements, and so sorry, there were some other aspects we were talking about, okay, but we didn't go much further than that. Okay, sorry, we had one topic. A topic also discussing about things that we can quantify and things we can't quantify. Okay, I don't remember whether we had a conclusion on that one. Okay, but still there is no clear convergence about what to do. Okay, and several concrete questions like which one was it? Typically, the kind of scenario we are dealing with, we're talking about something like a simple navigation scenario. But even in this case, so if we take this line in the document about the autonomy, okay, that's how far do we go? Okay, so it seems that the purpose today is so to discuss more, to brainstorm more, and maybe also to scope more precisely the kind, to scope more narrowly the kind of thing we could be working on. So, has someone a better memory of where we stopped last week? I'm sorry, I'm just starting to boot my system here.
I think we had two open conversation threads. One was, I think, Mayor and Josh are arguing a little bit about relatively open sort of design directions versus mission focus. And we continued that argument a little bit in the Discord. And the other thing was Joshua brought up the agriculture bot, which he thinks is a good candidate for us to converge on. And there's a thread on that in the Discord. So if you share the Discord and look at that AgBot thread, that and the last two comments in the main channel should be a good refresher.
Okay, so the thread is the one. No, it's not the one on the Yearly Commons. It's the new AI-powered farming boat, right?
Yeah, the two-wheeler with the counter-rotating back thing.
Oh yes, Yes. So sorry, can anyone see that the thread? Okay, it's the thread list. I'm trying to find how to be able how to share the maybe like that.
I have it. Let me share.
Sorry, thank you. Maybe like that.
Yeah.
Oh yeah.
So AI-powered farming robot. So
here we go.
I like this spoke-like thing, but all of them are the same concept. It's two wheels. This one seems to have a rear wheel, but many of the others seem to balance with a counter-rotating thing in the back. So
The
not
middle one is
quite
magnetic for climbing ship hulls, so the magnet attaches.
All right. Yeah, I didn't realize you had joined, Yasha. So you want to like talk about this?
Oh, sure. Yeah. So this was just at the end of the last meeting. I was just kind of throwing out there, see if anybody here sort of felt alignment with it. But this, what I consider to be one of the simplest, cheapest kind of robot implementations, is a tube with two wheels that has a tail, and that's it. And yeah, so there's a number of kind of commercial ventures that use this design. I linked 3 of them at the beginning of the thread. One is in agriculture. It's a terrestrial image capture product. So they're really they're capturing images is their main thing. And they also have a camera in their tail as well. So for plants that have higher foliage, they're capturing images from below that blue deck looking down, but then they also have a camera pointed up on the tail that's kind of hard to see in the photo. So it looks from below within the leaves and also from above down on top of the leaves. Yeah, so the second camera is in the little green thing in the tail.
Wait, so where's the tail?
It's that, you see there's a tube that kind of goes down. It's hard to see in that photo. But trust me, there is a tail that just kind of drags.
Okay. I trust you. When I saw it didn't have a tail, and that's why I liked it better.
Isn't this similar to the robot some Japanese companies trying to send to the moon, except the tail part?
I don't know that I've ever seen a lunar, like a spaced version of this design that has.
There was, I think Eric had posted some company's name, and then they had a robot similar to this one, except it didn't have the tail, and they were trying to send it to the moon.
Yes, and they're on the way actually to do that. It's only 2 wheels. Okay, it's more like the tube without the how you call it, the kind of tail.
Oh, is it
the torque? Yes.
Is it inverted pendulum, or is it just like it has a weight below the wheel axis, so it kind of just rolls around like BB-8?
So I don't remember the detail, but the thing is that no, I don't remember the looking into that actually. It's just that physically it's like just a tube with two wheels. Okay, that's all. Okay, and I'm trying to find a link to show it now. Sorry, let me try to find the link first.
But yeah, so after that, I just took like, I don't know, 20, 25, 30 minutes and just drew up a concept model in Onshape there. And the link is shared, so anybody can just look at the model in the link. But yeah, it's just kind of a conceptual model of what that might look like. And it's just, this is a solar charger, USB solar charger that I literally got for free at a trade show. So I was just like, effectively, you take this and put 2 wheels on it and you're done. Like, you just take the free solar charger from the trade show and let it roam. And that's pretty simple robot. Pretty simple.
But what about the brain?
You would strap on a brain. So that's certainly why I've modeled it, right? So it's kind of one level of fidelity above literally like duct taping things together. So you could actually sort of 3D print that architecture and then put the brain in there and the motors and kind of call it a day. Yeah, I mean, like the brain that you would put in there is a function of the workload you want to put on the brain. So that's like, you know, separate discussion. But the power required to run the brain is, you know, determined by that workload. So this is another kind of like top-down design approach thing.
So can I ask, in what sense is this design modular? You know, we talked about we want to make modular, we want it to be a kit in the sense that you can do stuff with it. So what you're describing is a very basic, simplest design. Okay.
I think that's true. Yeah.
Kit that can, so how do you envision expanding this into something more kit-like?
I think there's a number of different ways that you could kind of part it out to become more modular. I mean, it really depends on what you define as sort of like the molecular unit or the atomic unit for the system. So for instance, I think there's one version where this entire robot is the atom and the tail is an accessory, but then you can link these multiple little solar robots together. So you could take two of them and snap them together, and then it's a four-wheeled robot instead of a two-wheeled robot, and it has no tail.
Okay.
So it's like one way to break it up, to have sort of this like modular snap together kind of form. The other way is to actually make the solar and the wheels snap togetherable, where those components themselves would be, you know, the atomic unit. So then this robot would be a molecule of like three or four atomic units instead of itself being the atomic unit.
And would you put the motor and the controller inside the wheel?
Yeah. Well, wait, inside the wheel itself?
As part of a model, okay?
That depends. You know, part of my constraint for this was cheap. And so like there's a little motor you can get from Asia for like $16 that could run that spec. And that particular motor would not be fully integrated into the wheel itself. And I actually think in this case that might be fine, just because you know, again, it's kind of a small enough form factor that all parts of it fit in a typical consumer kind of like additive, you know, manufacturing.
So I have a thought here on modularity. One of the more interesting components to turn into a kit-like module is the wheel. That way you can have smaller and larger wheels, different tread patterns, that spokey looking thing versus like, you know, a more conventional circumferential wheel. And if you integrate the motor into the wheel, that makes it a much more expensive swappable module. Whereas if you integrate the motor into the chassis or body, that makes the wheel a cheaper swappable unit. And then there's the intermediate modular possibility where you have a hub-like thing that attaches to the body, and then the wheel fits on top of the hub-like thing. So we have like basically three options for where to put the motor: on the body in a separate hub that attaches to the body, or integrated into the wheel. So, but yeah, to Mayor's broader question, I think this design actually offers a lot of room for modularity and kit-like explorations. Maybe not as much as like a completely generic Lego-like vocabulary.
No, I'm not sure about that. Let's take this one step up. Let's assume for a second that the body is basically what Red showed us when he took that toy kit and enhanced it. And let's assume that, you know, you have the body, and then you can attach a motor module on either side, and then you can attach a wheel to that motor module on either side. And if we find a way to expose power and data connections, and because Joshua, the design you gave is very flat, so anything, you can put whatever you want on top. So we could have an actual modular system. You want to add a camera, you have a little box that has a camera and it has a data connection, and you put it on, and now you have a camera. So we can take this basic design, and yes, with these replaceable parts, and make it kit-like by exposing, since we already have a somewhat standard mechanical connection, we can expose a data and power connection to be more standard.
I mean, so the other reason the reason why I suggest this design is like, that design is so simple that it actually is feasible for, I think, this current group of 6 people on, an hour or 2 a week to actually finish, ship, write firmware for it, and put it in the desert in like a few months. That's actually feasible. Once we start getting into this is the thing about modularity, and this pattern shows up in every modular thing I've ever come across or touched.
Mm-hmm.
Once you add modularity, there's interface overhead. And that interface overhead exists on all levels. So that exists on the physical level, electrical layer. It exists on the software layer. There's just every single layer. There's a bunch of, I mean, this happens in software too, where you're trying to like go object oriented, and there's this layers of kind of like barrier you have to create to have this really clean interface. So it's like the interface may be cleaner, but then all of the infrastructure supporting that interface gets thicker. So for instance, if you want to have cameras that are modular and addable to this robot that we have, that would require creating a fully weather sealed and IP rated camera module, connectors that are also fully sealed and weather rated, and then the harness that can deal with being outside. And all of that added immense overhead to the cost and design. Whereas if you had just put the cameras inside the big sealed box in the first place, you wouldn't have to deal about any of those constraints at all. And so I just want to point that out, that like there is overhead and cost associated with modularity in my experience.
Where did you get this IP68 resistance from?
We're putting it in the desert. That's what I'm saying.
With everything you're saying,
this thing could ship. That's what I'm saying. It could like actually go out in the California like downpour. Like this isn't a little thing that needs to sit in your lab. This is like throw it. That's what I'm going for.
Yeah, well, that's what Yakko or whatever it was called was about. The question is, are we trying to build a robot? Or are we trying to build, forgive me for using this bad word, platform? The whole idea of having a kit, which is modular and you can fiddle with, is that you don't just have one way of doing it, and that you are able to, at home, play around and change stuff and add stuff. So personally, I'm willing to give up on it working in the desert in the middle of a downpour storm if it means that one person will add a LiDAR and one will add a camera and so on.
I'm not sure why we're arguing about this like one precludes the other. To me, these are like two directions that achieve very different things. Like we can start with, just to back up a little bit to build on, sorry, I have a sore throat, Josh's point. In my experience, most things that are modular or kit-like start out monolithic, and then gradually people figure out how to modularize and sort of break it up into kits. So that's a sort of side point. Happened with like semiconductors, for example. But setting that aside, I think the intent of this kind of like, let's get to the desert as quickly as possible is really push the boundary towards the long-term mission of like, open source space program or whatever, and get as far as we can, as quickly and cheaply as we can. And I think that intent automatically suggests, let's build the simplest, most robust, fewest moving parts, fewest connections, modular, cheap thing that we can as quickly as we can, and get it into the most extreme environment we can early. So that's one vector. Another is, let's sort of set up this set of concerns we want to explore, like modularity or platform, and approach it from that side. And to me, these sound like two different projects that don't need to preclude each other. And looking back on the last 2.5, 3 years, I feel like we've been doing more on the latter end, like kit-like explore kind of stuff. And we've never actually challenged ourselves to do the new direction Josh is suggesting. So I think that would be a good stretch goal, and we don't have to give up one for the other. The desert mission can intend to become modular, like after the first iteration. Like if we have one successful day in the desert, then we go back to the drawing board and say, how can we break this up? How can we accept 50% more cost to make the connections more modular, blah, blah, blah. So we can do that. And on the other hand, we can also do this parallel design exercise of how do we do purely from scratch modular kit. So I think we have enough bandwidth to do both here. And I'd rather not choose. It doesn't seem like we should be doing only one. We should be doing both things. One is, theory, concept exploration. The other is capability up leveling. This, like one of the slightly frustrating things for me is, for various reasons, both individually and collectively, it feels like we've stalled out at a certain level of capability and are struggling to level up one more step. And this feels like a way. I know. Yeah, I'd like to hear from the others too. You've been silent. Three of us have been dominated.
Yeah, I'd like to say that. Oh, go ahead.
Please, Red.
I was just going to say that I think the goal of building a platform, while interesting and maybe needed, it was really difficult to do if you don't have a lot of experience building the thing in a monolithic prototype, just ship it kind of way. Like, I think if you do that a few times, you'd have a whole lot more kind of context on what a platform would need and how you do it. So I think having a forcing function of having a working rover is could be very valuable.
Yes, I have a comment that is pretty much the same thing that what Fred has just said, but from a different perspective. Is that first, for example, desert is an extreme environment. Okay, so in some sense, a city is an extreme environment. Okay, but a desert, we know we push several environment factors to some extreme by some measure, okay, temperature, humidity, and so on, okay. And so designing for that is definitely more challenging. Okay? It's like designing for space, so which would be maybe one step toward going to space. Okay? And so it seems to me that we should maybe aim at something simpler than a desert, to some extent. Okay, but on the modularity side, okay, this is another completely different set of challenges, in my view. Okay. And I wonder whether we need that. Okay, so that's why if we go back at the beginning of the thread about yearly comments, whatever, the proposal is actually simpler than modularity or extreme environments. Okay, it's exactly what Red said. Is first to build something together. Okay, so something perhaps simpler, perhaps less exciting, but something that exploits our different skill sets. Okay. Because we are very lucky to be a very complementary team in terms of skill sets. And first, do something to the end together, okay, as a kind of stepping stone to think that the next year then, based on what we have achieved, when we would have achieved this year, then we could decide to go toward, okay, let's push further on the extreme environments dimension, or let's push further on the modularity or something like that. Okay. So thank you for sharing the screen, Venkatesh. Yeah. So you see the first line is year goal is to reproduce a common robotic rover tutorial with our own tech. Okay. So maybe that's less exciting, but it's something that we can achieve definitely with just a few hours a week, perhaps. Okay, and it's more about the protocol of working together. So sorry, Venkatesh, I'm not using the word protocol as excited these days. Okay, but it's more about okay, what does it take to complete a robotic project together? Okay, so the interaction between us. Okay. This is why that's why I'm using the word protocol. Sorry. And first, In fact, that's it, basically, okay?
Well, I'm for anything that gets us unstuck. We have been like kind of stuck for a while now, I think.
So to Eric's point of like just learning to work together, maybe one thing we can do is actually next few meetings just alternate these two sort of proposed tracks. Like 1 week we try and get as far as we can on the two-wheel, eventually extreme environment intent type robot, but maybe not immediately. Maybe our intermediate goal is just getting that kind of robot for non-extreme environments. So the immediate thought that occurred to me was, I can't do PLA 3D printing if we are putting it in like extreme desert. It has to be ABS at the very minimum because ABS can handle higher temperature. So like I can already see problems with trying to go extreme. But yeah, so we take alternate meetings to work out basically a shared design one step at a time, and the other alternate meetings to start sketching out like a modular thing. And maybe after a trial period of like 3 + 3, 6 meetings, whichever feels like stronger, we double down on it or something like that. Does it make sense?
Yeah.
I don't know if we have the energy to do two things at once.
That's why we stopped doing one of the two things after 6 weeks. Because I honestly don't know. There's too many unknowns here. Like just another little data point from my individual experience. I feel like I started out too complicated with my 6-wheel rocker bogie, 15 different mechanical things and complicated wire harness model. And if you guys recall, I had to like set that aside and go back to like a single printed part and 4-wheel simpler robot in order to get to the point where the robot was moving at all. So I had to already go back from more modular to more monolithic to like move on the vector of more complete robot, and it's still stuck there. So I think my limited experience suggests that going back towards monolithic is more likely to make progress. But I'm also really interested in like the platform and kit design stuff. So at least for a limited time, I'm willing to continue exploring more. Maybe not 6 weeks. Let's how about 4? 2 on each vector. So we could do something like, all right, week 1 on the 2-wheel farming robot, we work together on the CAD design and sort of like work that out. And second session, we maybe work on the power and motor or something like that. And similarly on the kits side, we kind of like decide what are the components we need on the first session, and second session, we try to design a few of the parts, something like that. We can work it out, but it shouldn't be hard to do like trial design sessions together. And it'll be kind of interesting. Somebody will have to lead though.
Indeed, yeah. For me, there is something perhaps interesting to investigate along the lines proposed by Venkatesh. Okay, is the image is some kind of funnel, okay, where basically, as a distributed team, how can we, perhaps the challenge is how can we achieve anything by the end of the year? That may be the actual challenge, okay? Because if we look at, for example, famous, flagship missions to space, okay? Usually it takes longer than is planned at the beginning. Okay. Well, I think most projects we all do take longer than what we plan at the beginning. Okay. And so, are there ways so that we can, we can create some kind of checkpoints where we have targets that are less, that are at first very, very rough, okay? And we refine step by step. What I mean by that, so this is where the funnel image comes in, okay? Is that it seems to me that at the very beginning, for example, okay, it would be more working on shape, okay? Why? Because it's virtual, okay, and it's we can all work in a distributed way, okay. And on people who are really familiar with CAD, it's really about starting to design, but not to design at a fine grain, but roughly, okay, what are we talking about, okay? And other people, especially, for example, people on software or electronics, okay, that where they have nothing to do at that point because it's not yet specified, or we don't want to decide yet, basically. Okay, what can we do at this stage together? Okay, and it's a very rough, so it's like a big bounding box. Okay, and we want wheels or we want legs or whatever. Okay, and as we work together a little bit and start making some decisions, okay, is start refining. Okay, and at some point we refine enough to say, okay, we have a box that will host a Raspberry Pi, whatever. Okay, and so boom, we have a first very simple decision, or okay, we take the Raspberry Pi for now, because around that box, people for the CAD, they can keep designing to refine other aspects around the Raspberry Pi. Okay, while people on electronics, they know what their base is, and for software also we already know. Okay, we have Linux and we can use Python, whatever. Okay. And then the next step is to go finer. Is that on CAD and mechanical design, we make some refinements where we make more and more decisions. Okay, like for example, we decide on 4 wheels, for example, okay, or 6 wheels with a rocker bogie. Okay, and so step forward like that, and that fits electronics and software. Okay, so we need to software for 6 wheels, for example. Okay. And we start either finding a library that does that or coding it ourselves. Okay? And we continue like that. Okay? Am I making sense on the trying to do a bit of storytelling where it's a kind of funnel where we refine step by step? And so we postpone several decisions for later, okay? Especially final decisions.
I have a feeling this it feels a little bit like slightly heavyweight project management for the level of small scale fumbling we are doing. So a version of what you're saying, I think that would work better for this size group is yes, not everybody can or wants to participate in every subsystem or something, but rather than do project management and fork a little too early, we can do something like fish bowls. By that I mean, for example, if Joshua, I, and Rhett, since we've played with Onshape and CAD, we form like a 3-person sub-team that in one live session, we are like brainstorming and pulling the mechanical design together. The 3 of you watch, and I think watching will itself be interesting, learning and get a lot of implicit project management done. And then the following week, when a different subgroup is like brainstorming and like locking down the specs of the software environment and libraries or the electronics or something, the other people watch, because I personally would in fact like to watch people basically think out loud so I understand how the design thinking works, how you work from like 10 different options and narrow down to 2 and pick one. So if we do that a couple of iterations, I think we'll get enough design output on the table that then we can do a little bit more formal project management and like fork into tracks and do iterative refinement like you're saying. But right now it feels like overkill, at least at the beginning. So right now, next few sessions, I'd like to just get into it and like, organize it later.
Oh, thank you. Just to be clear, this is what I wanted to say. That is what I wanted to say. Okay. I'm definitely not wanting to do any project management. Okay. I was just trying to describe, okay, over time, what it would look like. So it's more like a funnel. Okay. But how to do it is by sitting together. As long as people don't watch too much how I code, because that can be like watching how an octopus works. So yeah.
Yeah, but that's actually part of like, I think you nailed the challenge right. It's the hard part of this is actually figuring out how to work in a group like this at all, where the design constraints are. There's 6 of us with varying levels of different skills. We have limited amounts of weekend and evening time to devote to this. A lot of work, ideally 100% of this should get done in like live co-working sessions to the extent possible, because realistically, like whatever we do in this meeting is like a big spike of work. And then in between, if we're lucky, something else gets done. So that's actually the engineering design challenge. Like, how can you actually work in that mode and get anything done? Because if I were doing this as a completely solo project, I suspect I'd move much faster because I wouldn't be trying to collaborate with people. I'd be cutting corners, making efficient decisions and so forth. So building a robot like we're talking about by ourselves, one person, is actually not that hard. But doing it together through a protocol is in fact the hard part of this. Because if we figure that out, then we can figure out how can we add 10 more people to the team? How can we like actually do something much bigger with $100,000 budget? That's like, it's a series of realizations. Like when we got into this, I thought the fun and hard part would be the mechanical and electrical, because that was the part I didn't have any hands-on experience at all. Then eventually it became clear that software was harder than the mechanical and electrical. I think we are about to find out this year that the human coordination is harder than the software as well, right? Something like that. And we'll go up that hierarchy of, once we figure out how to get like a 10-person team building an open source rover together, we'll find out that the actual hard part is like working around regulations of like trying to get anybody to launch anything even into the Earth atmosphere. Like suppose we want to do like a very lightweight rover launch and parachute down test up to 10,000 feet. I'm sure we'll run into like 50 different things we've never thought of in the regulatory environment. So anyway, that's my sense of like, it's a narrowing funnel on the design spec, but a broadening funnel on like what is difficult and at what stage, and like, you know, leveling up on like where the difficulty bottleneck is. Like right now, I think 6% coordination is the difficulty bottleneck.
Yeah.
It's also not like any of this can change. Like this direction can always change. But yes, the point where I'm definitely coming from is like there's not enough robot. Need more robot.
Oh, and we also have the third track that we kind of forgot about, which is all the sort of like try the latest technologies out and play with them one by one. So that was kind of the learning track, and we still have your incomplete Isaac Sim NVIDIA integration demo you were going to do, and I think Anuraj, you were going to do Coppelia Sim, and there's a bunch of other things like that. At some point, I'm guessing one of us will want to like take AIs out for a spin, say can or something like that, whoever is closest to getting that.
And the beauty is all of that happens independently of the particular platform that may or may not be built. So that's the nice thing, is like all of that simulation activity and research and study is just as applicable for either the two-wheeled thing or a spider or whatever.
Yep. All right. So are we in agreement on trying like 2 tracks, 2 sessions each, alternating weeks for 4 weeks, and basically deciding which one looks more promising to double down on?
I like that. I kind of was thinking of the other track that I guess they were calling modular stuff as like the independent research track of here's the other random stuff that we've been exploring. I don't know if that has any more precise goal than that. I mean, that's sort of what I wanted it to be anyway.
I think we could do that in a collaborative way. Like, again, mechanical is the easiest to think about since the visual intuition is obvious there. Like in the first session on the modular track, one thing we could do is just what parts do you want? Do you want a set of wheels, a set of bodies, and a set of like motor hubs and like connecting things? Should we use Lego and or Meccano or something like that, or just 3D print our own little kit of things? So we can make those decisions, sketch out some initial modular parts, and take a stab at like actually designing or like specifying them as a BOM. So that sounds to me like a collaborative starting point for the modular direction.
Right, to what you just stated, would it be what we were referring to as boot camps a few weeks back?
Yeah, I guess that's what I was. Are we still doing Hello Worlds as that other track?
Oh.
Or I guess we haven't really been digging into a modular focus, I don't think.
Well, I did
Or I
the
guess
session on Meccano a few weeks back. I think you missed that one, but you also did the one last year on your kit-like thing. And I think there's overlap there. There's bootcamp stuff. There was Hello World on lots of components and sort of an implicit intent of that can be a kit-like design sort of capability set. But I think we are also thinking in terms of like, can we actually make a YARG kit, which we can describe and document and maybe provide reference designs for. And at the end of the year, we have a few reference kits available. New people can join and like, download and use the kit. So that's the whole thing, not just a set of like design. I think the two distinct ones are there's an actual kit of like components that people can use versus almost like a set of recommendations of use an RPi over a BBB or use this or that kind of. So I don't think of that as modularity. That's more like study stuff, get to Hello World and make recommendations. That's more like analyst. Yeah, I would call that an analyst report on the emerging new robotics world or something like that, which is also an interesting thing to have. I would like to have that right now if it existed.
What is interesting is that I mean, if we think about how this could roll out over the year, okay, is that if we take roughly the topic of mechanical design, electronics, and software, okay, there is more than that, okay. It's not. We are not going to do software right away because to do software we have to make some decisions. So software will most likely start later. Okay? And first, to me, it's more like okay, it's on shape, starting to decide several parameters, I would say. Okay, and so while on-shape experts or CAD experts lead the sessions, the first few sessions with on-shape, okay, other people, so for example on software, can prepare something else. Okay, so here as an observer, so the fishbowl image, okay, as an observer and also contributor to make decisions, preferences, and so on, but also maybe doing something like a Hello World, like looking at the modularity from the software perspective, or talk about a new simulator, whatever. Okay, and so some sessions would be some design together where some people lead and some people observe. Okay, some sessions later the week after can be to talk about some bootcamp topic. Okay, and the week after again. Maybe again on shape, or maybe we move to another tool together and so on. Okay, and the roles change. Okay, inside the team, because some people at some point lead and the other observes and maybe do some study on their specialty, and later down the road, 2 weeks later, it's the contrary basically. Does that look like? Am I making sense as an image, talking in the air like that?
Yeah, that makes sense to me. Yeah, so I think we're just gonna have to try this path and see how it works. Lots of things are going to go like we thought. Other things are going to go completely weird. So.
Yeah. Oh, and thank you. And also, what I'm trying to say that in a way there is no idle time. Okay? This is something. If you take a very standard software project, let's talk about making just a website. Okay. For me, there is always a simple problem is when design is not ahead of engineering. What I mean by that is that in a team of 3-4 people, okay, if we don't know already, if we don't have a common image about what we want to build, okay, so maybe the layout of the website, okay, and maybe some styling of the website definitions, okay. Engineers can get lost pretty easily, or they can just make a patchwork that hardly stands alone. Okay, and so usually what we're trying to actually most of the time how I'm trying to work, okay, is to have designers be at least 1 week ahead of the engineers. Okay, very simple approach. Okay. So that they make some design propositions, okay, and we discuss them at the business level and stuff like that until we settle down on some decisions, basically, so that after engineers can just implement them. Okay, they know where they have a North Star and they know where they want to go. Okay, and here it's a bit, but so by doing that, everyone is busy, because if we look at that over time, is that designers prepare the week after, while the engineers are implementing the current week. Okay, and so the next week, everything is shifted by 1 week too. Okay, the designers are working for the new. And doing that, everyone is busy, and it's pretty smooth, basically. Okay. It seems to me that we are talking about something similar here. Okay, where some people leave the CAD, and while software engineers observe. Okay, and later the CAD is stable, so people from CAD they move to some other topic, maybe studying, while the engineers lead the sessions. Okay. And during that time, the CAD people, they focus more on the 3D printing part, for example, I don't know, okay? But more on the observation, on the exploration, okay? Until the session come back to do some CAD, maybe on the printing side, or reporting, showing, stuff like that, okay? So the more I talk, the more diluted it gets. Okay, but it's just trying to describe how this thing could roll out over the year. And maybe trying to make the point that everyone can be busy all the time.
Can we decide more precisely what we are going to do for the next 4 weeks? Is it the kit part or the?
So I think next week, since Joshua already got it started with the two-wheel design, that seems like a good starting point, since he's already gotten that started. So if we can start with that and refine that design, and then the week after, Mayor's, since you've been sort of like championing the modular direction, if you can lead an initial design brainstorm session for the modular direction, and then the following 2 weeks, I think, will get suggested by the first 2 weeks. Because I can't even think 2 steps ahead right now. 1 step is like, feels doable.
Okay, so I'm available in 2 weeks, but not in 3 weeks.
Yeah, so.
Oh, okay, I'm just making sure you know the schedule.
Okay, yeah. Yeah, that sounds good.
I mean, I also just want to be clear. I think a fundamental challenge that we have here is work packages, if you will. So it's like you can use some stuff and then deliver it, but in a way that it sort of like unlocks other people to also create packages and deliver it. Because yeah, there is this sort of like rapid serial execution that can happen as an individual, where preemption by other people's work packages could be blocking or interrupt. So figuring out how to get that architecture to work in this team, I think, is critical. Because for instance, for me, spending a half hour in Onshape and delivering a proof, like just a concept model, is like a work package that I've delivered and just like freely, like it's there. If anybody wants it, like you can go remodel it, do whatever. Like it's an open for whatever work package. I think figuring that out for all types of deliverable, including software, hardware, whatever, will be important for the open source like community around this to be sustainable, and defining how that can look.
So just one remark is that for me, I really like that, okay? But one thing is that defining work packages and so on is more about project management, okay? So that's one aspect, okay? So it can be seen as overhead. But on the other hand, for me, there is this image of HPC, high performance computing, okay? And so HPC is about normalizing your workload, basically, okay? So making a work package to parallelize on a GPU or to parallelize on a cluster, basically one of the common technique, okay, is to normalize the task you want to send to your cluster or whatever, okay. And so normalizing means, it's have a standard format for each workload you want to send to your cluster, okay. And what I'm trying to say here is that we can see that very high volume work, very big projects, and also high velocity teams, okay, tend to work like that. Okay? So I wonder whether it's not a project management that is beneficial. Okay? So another point, it's not to see it as overhead, but as actually good preliminary analysis of what to do, okay, so that we can work efficiently, okay, and in a decentralized manner.
I'd like to comment on that, just that I don't see it in a project manager sense, because I do know that that is one way to look at it. What I really mean is it's an autonomous self-management construct. It's not somebody else, it's an internal construct. And I even do this with myself, because like I have so many weird little projects I work on. Like if I preempt myself before completing a work package, which could include things like commenting on what I did and submitting that to a repo, if I get preempted and come back to it, I have no idea what I did. And I can't even continue working on it with my own preemption. So it's like, if I can't even resume after preemption on my own output, then how could anybody else? And so that's just a thing that I've tried in my own self, like do a little thing, push it to a repo or write a comment in some notes somewhere. That's like a thing that I think facilitates preemption and resumption of a task autonomously, not necessarily involving, like in the literal sense, a project manager entity.
Yeah, I think you actually just described research challenge into modularity. Like modularity is not just about the components that go into the robot. It's about creating modular components of work itself that includes the person doing them. So one way to think of it is work and effort should not be wasted or unnecessarily like reworked. So if somebody spends an hour doing a bit of design and produces something, it should not go to waste. It should be like properly annotated so it can be resumed. It should be put somewhere where it can be found. And if that direction is like chosen as we want to continue building on this design, either that person or somebody else should just be able to pick it up and continue that. So I think of this as actually a very good open source, engineering process research challenge. Like it's as important as actually building a robot to build this process that can build a robot. But we have 5 minutes left. I did want to raise one thing. Time, do we want to move, so next week after all the daylight savings finish, I think on the calendar it moves back to noon my time. But Eric, will this be too early for you? I think you're the main one who's not in a daylight saving zone.
So you mean to move? For me, that would be 1 hour earlier.
Yeah, for all of us. But for all of us, I think will be generally easier, since 12 instead of 1 probably works better for me. And especially, I think actually Anuraj and Mayor, it will be 1 hour earlier for you, so 1 hour less sleepy. So that'll be better for you, I think. But Eric, it'll be super early for you. So I think the 3 California or West Coast people don't care either way, but Japan and Central Europe care.
Okay, so for me, it's possible, or at least it's. I used to do that, but the thing is, I'm the only one who is not changing time, right?
Yes. So
we changed time when it was still winter time.
Oh,
when we set up the time, it was 5 a.m. for you, but now it's suddenly 4 a.m.
Yes, but the thing that I'm trying to wrap my head around is that everyone's time will be virtually the same. So if it's 1 p.m. for you, it will still be 1 p.m.
No, it'll be 12 p.m. for me.
Just me.
No, next week it'll be 12 p.m. for all of us on the U.S. West Coast. and it'll be 1 hour earlier for Anuraj and Mayor, and for you.
But the calendar shows 10 to me.
Wait,
My calendar.
did somebody change it? Hold on, maybe I'm. No,
Okay,
mine.
it doesn't matter. The only one here is Eric. Eric, what time is good for you? And we'll let the computer tell us what time everybody else is getting it. Because
Yes,
Venkat is right, you know, an hour earlier for us is nicer.
yes. For me, let's try with what will end up 1 hour earlier for me.
That's what it
This
looks
is
like
why.
on my calendar. On my calendar, it says 12 p.m.
12 p.m. and on mine.
So I'm really confused by whatever the hell is going on here, but I'm assuming my calendar is correct.
So the only thing is that let's make sure that the calendar entry is created in a calendar where on a time zone where there is DST. Because if I create it, it doesn't adapt automatically. I had a problem in several of my
This says
groups.
it's created by Mayor. So Mayor, I think your times, this must be Israel time zone, right? If you can see my screen.
I can see your screen. If it was created by, no, but it doesn't have to be I can create it on somebody else's time zone.
But right now it is on this. So yeah, maybe since you
No, I might have created it on Pacific time zone.
Okay.
So sorry, I can see that for me from next week, the meeting is one hour earlier. Okay, and I see also my calendar saying that that some countries change time next Monday. Okay, in the UK and in Sweden where I work, they change time next Sunday. Sorry. Okay, and for me next Wednesday is 1 hour earlier. Okay, so apparently it's automatically adjusting.
All right. So next week, I'll post a reminder just before we start at what I believe to be the correct time. And if I'm wrong, people can correct me. But all right, so sounds like we'll be meeting all of us 1 hour earlier next week, which is back on the time that it was 2 weeks ago. So that's good. All right. Okay. I think we are set. And next week, I guess we'll be building on the little 2-wheel design.
Cool.
All right.
Oh, great. Okay.
Bye.